It's time to learn about determinants. Now, the first point I want to make about this is to compare it to something that we already know, which is a good place to start whenever you learn something new. So I want to recall this thing called the norm of a vector, or the magnitude or the length, whichever way you want to look at it. Let's calculate a norm here. So evaluate the norm of the vector 1, 2, 3. Now also, I might add that we probably used these for vectors before, but that's not all that important. They're vectors when they're just tuples. When you're mixing them together and you have points and vectors, they're really all just vectors. Okay, so let's just move on from that point. How do you do this? Well, you just take the square root of 1 squared plus 2 squared plus 3 squared, which is the square root of 1 plus 4 plus 9, which is root 14, and we are done. Now, here's the point I want to make. This is a vector, and I perform some operation on it, and I get a scalar. That is my point, okay? So this thing that we're going to be studying called the determinant is going to be something that eats something that's like a matrix and spits out a scalar. So just like the norm eats a vector and spits out a scalar, this determinant thing is going to be a similar kind of piece of machinery. So let's just start with the 2 by 2 case because it's easy. Now we actually already know this from the past. We learned it back in Calc 3 here. So if A is a 2 by 2 matrix, A, B, C, D, then the determinant of A is AD minus BC. So it's this cross-diagonal thing, right? So multiply these and subtract this from this, right? So AD minus BC, determinant A. So let's do one. This is pretty straightforward, right? So it's going to be 1 times 2 plus negative 3 times 5. Whoops, I meant minus. And so I get 2 plus 15. That was why I said plus. I sort of did the thing in my head early. And 15. All right. So there's our determinants. Done. Next, what about this one? So 2, 9, 3, 6. So I have, or I should say D team A. Determinant of B is going to be 2 times 9 minus 3 times 6, which is 18 minus 18 is 0. Okay, and we're going to talk about this more later in the section, but something you can kind of notice here is that if you take the first row and multiply it by 3, you get the second row. And that kind of thing in the past said that this kind of matrix was going to be not invertible. And so invertibility and a determinant being 0 is going to be a thing, all right? So something to keep in mind as we go forward. Now that's the 2 by 2 case. They're very straightforward. How do we do this for bigger matrices? Well, we actually have to do quite a lot. This is one of those things where the sort of way to build it up is significantly more complicated than you feel like it needs to be. Okay, so let's do this. If A is a square matrix, so we're only doing this for square matrices, then the minor of entry Aij, denoted Mij, is defined to be the determinant of the submatrix that remains after the ith row and jth columns are deleted from A. Okay. So what we're going to do is we're going to take a matrix like this, and the minor of this entry, what we'll do is we'll take out that row and that column. It's going to be the determinant of the leftover matrix down there. Okay. Then the number -1 to the I plus j times Mij is denoted Cij and is called the cofactor of entry Aij. All right, and I know that's almost completely nonsensical, so let me do some examples and it'll make sense. I'll come back to that remark 9 in a second. Let me do some minors. Let's find minor M11. So minor M11, here is the 11 thing, the 11 entry. We're going to erase that row and that column. And so this is simply the determinant of what's left. 3, 1, 1, 2. Okay. Absolute value bars mean determinant. I'll officially define that later, but to save myself some space here. Okay, and then it's just going to be 6 minus 1 is 5. Cool. Okay, again, 6 minus 1. All right, what about M23? Let's get rid of that, change colors. M23, so I want the second row, third column. So here is the 2, 3 spot. We're going to ditch that thing. And so it's going to be 1, 2, 1, 1, which is 1 minus 2, which is negative 1. Very good. One more color. M3, 2, so third row, second column. Here's the 3, 2 spot. We're going to ditch that row and that column. And I get 1, 0, 0, 1, which is 1 minus 0, which is 1. Okay, so those are minors, right? And in a 3 by 3 matrix, you can compute 3 times 3, 9 different minors. Okay, so every entry has a minor. And there you go. Now, you're already thinking like, well, what do I do for bigger matrices? Well, we'll get there. Okay, now the cofactor is going to be negative 1 to the I plus j. Now, let's just think about what that is. In the 1 plus 1, negative 1 to the 1, 1, in the 1, 1 spot, it's 1, right? And so that's just a positive. So this thing gets a positive. Now, every time you move over one entry, right, that's going to be negative 1 to the 1 plus 2, right? When you add one more negative, it becomes negative. So when you move away one space, they become negative. And then when you move one away from those in any direction, you go back to being positive. So you have this sort of checkerboard of pluses and minuses. Okay, and so that's how you can find the cofactor if you don't want to just do the, this is the easy way of doing the cofactors that way. So C11 is officially going to be negative 1 to the 1 plus 1 times M11, which we already did, so that's positive 1 times 5, which is just 5. Now, the best way to do this is to just look at the 1, 1 thing here. It's positive, so it's going to be positive 5. Okay, let's do C23, the fancy cheater way here. So 2, 3, what I like to do is just put pluses and minuses. So it's plus, minus, plus, minus. Okay, so that means it's plus, minus, plus, minus. So the cofactor is going to be negative. And then the minor is negative 1, so it's 1. Cofactor 3, 2, what's that going to be? So plus, minus, plus, minus. Just sort of work your way to that entry. And that's negative 1, so that's going to be negative. The minor is 1, so that's negative 1. Okay, and now that is cofactors and minors. Now, what are we going to do with this? Well, we will find out in the next video. I'll see you then.